This is Algebra 2 with Trig. This is the review for Chapter 12 test. So this is starting with section 12.3. We need to tell whether it's geometric. Well, we can look here and we can see if we divide 5 by 3 and 7 by 5, we don't get the same result. But if we subtract 5 minus 3, we get 2, and 7 minus 5, we get 2, 9 minus 7, we get 2. So we know that our D value is 2. So is it geometric? And the answer is no. The sequence has a common difference, which means it's arithmetic. Looking at our next one, we have 9 divided by 3, 27 divided by 9, 81 divided by 27. This does have a common ratio. So we can say yes. Here we're going to write a rule. We're going to find the sixth term, and then we're going to graph out our values. So we know R tells us this is geometric, so we're going to use the format of A of 1, R, and minus 1. This is the rule for a finite geometric sequence. Just a list of numbers that are being multiplied by a common value each time. So our first term is 2, our ratio is 3, and minus 1. We cannot call this 6. You cannot multiply the 2 and the 3 because the 3 is being raised to the power. Order of operations does not allow that. So A of n equals 2, 3, and minus 1. So to figure out A of 6, we're going to plug in a 6 for n. Three to the fifth is 243, and we times that by 2, and we get 486. So A to the 6th power would be 486. So if we were going to graph this, our first term would be 2. Then we times it by 3, so then would be 6. Times that would be 18. Then we'd take our 18 and times that by 3, 54. Times that to be 162. Up by 25 each time. So notice how the dots are not in a straight line. They're growing exponentially. Write a rule for the nth term of the geometric sequence. We have two terms here. We know that the second term is 2 and the fifth term is 1/4. We might be able to sit around and guess about how you might be able to come up with that, but if we follow our normal calculations, we're going to take the basic formula. We're going to plug in 2 for the A of n, We don't know the first term, we don't know the ratio, but we know the nth term. When do we get 2? We get 2 on the second number. So we can solve for a. So a of 1 has to be 2 divided by this ratio. Now we're going to take the other point, which is 1/4. Our first term is 2 divided by r times the ratio, which we don't know what it is for this. The fifth term gave us that 1/4. So we can reduce the r's. So that's r cubed. Now when we divide by 2, we're actually putting the 2 down with the 4. So that gives us 1/8 equals r cubed. And when we take the cubed root, then we're going to get 1/2 equals our ratio. So if we test this out, we're going to start out with 2, and then half of that would be 1, half of that would be a half, half of that would be a fourth, half of that would be an eighth, a 16th, and so forth. So the fifth term is a fourth. 1, 2, 3, 4. Well, let's figure out what our first term would be. Our first term, we need to, that's our second term is 2. So our first term, we need to plug it back into our a of 1. So that means we're going to take 2 times the reciprocal, which is actually 4. So it's good to test your work. Be sure that the numbers make sense. 1, 2, 3, 4, 5, 6. And we know that the fifth term is a fourth. 1, 2, 3, 4, 5 is a fourth. So our actual rule is 4 times 1/2 n minus 1. Here we're going to find the sum. We know that this is geometric because it's a ratio being raised to a power. So to find the sum, we're going to take a of 1 times 1 minus r to the nth power 1 minus r. That's our formula. So we need to find these different values. So a of 1 is going to be 90. The r value is 1/3, and n is going to be 8, because we're going from 1 up to 8. We don't need to know what the last term is. So a of 1 is 90. 1 minus your ratio raised to the 8th power over 1 minus your ratio. So that's going to give us 90 times, we want to put 2 parentheses because we want one for the numerator, and then we're going to have another set for the denominator, and the first set is for everything. So 1 minus 1 divided by 3 raised to the 8th power, that's the numerator, divided by 1 minus 1 divided by 3, that's the denominator. We get 134.98. So what that would be actually is taking our 90 and we are multiplying that by 1/3, and our 30, and our 10, and our 3 1/3, and our 1 1/9, and our 0.37, our 0.123, So 1, 2, 3, 4, 5, 6, 7, that's 7 terms. So our 8th term is plus 0.04. That's adding all of those up would be just about this value. For 12.4, we're going to graph the partial sums. So to do that, we're going to graph the first term. So S of 1 is clearly 3. So our first term is up at 3. Our second sum is going to be 3 plus the 3/4. That gives us 15/4, which is 3.75. Our third sum, these are partial sums. It's going to be the first two, which was 15/4, plus the next one, which is 3/16. That comes out to 63 over 16, which is 3.93. Our fourth term is that 63 over 16. That's the exact value, so that's why we like to use the fraction. And we're going to add it to our next term, which is 3 over 64. When we get common denominators, we figure out that that's 255 over 64, which is 3.98. And then our fifth term, add that on. So we're going to take our I believe 255 and add our last one to it. So notice that this is the previous four terms all added together. That's going to end up coming up to 1023 over 256, getting common denominators. And that still is just 399. So notice that this is approaching 4. So explain what's happening. The partial sum approaches 4. Next, we're going to find the sum of the infinite. We know it's infinite because it has the infinity sign on top of the sigma. So there's a formula we use for this. So we need to know the first term. So when you plug 1 in to figure out your first term, you know your a of 1 is going to be 5, and your ratio is a half. So the sum is going to be the first term divided by 1 minus a half, which comes out to be 10. Here, our first term is going to be 3, because when we plug in 1, we get a 0 as an exponent, which is 3 times 1. The ratio is negative 2/5. So we'll be able to find the sum as 3 divided by 1 minus negative 2/5, which is 15/7. About 2.4, 2.14. So you want to be sure you know how to use your calculator to make that happen. A of 1 is 6, R is 2/3, so the sum is going to be 6 divided by 1 minus 2/3. It's going to come out to be 18. a of 1 equals 1. The ratio is 5/2. Now notice how the ratio is greater than 1. We only use this formula if r is greater than -1 but less than 1. So r is too big. R is greater than 1. So this has no sum. The numbers just keep getting bigger and bigger and bigger when you start to add them together. It does not approach any value. So we're going to find the sum of the infinite geometric series. So doing some of the same, we're going to first show that this is in fact geometric. You take the 1/4 and you divide it by 1/3. That's going to be 1/4 times 3/1, which is 3/4. And then if you take 3/16 and divide that by 1/4, that is 3/16 times 4/1, which reducing comes out to 3/4. So we get this common ratio all the time. So our first term is clearly 1/3. Our ratio is 3/4. That's what we didn't know for this. So we're going to figure out the sum, which is your first term, 1 minus r. In this case, that's 1/3 over 1 minus 3/4. It's going to come out to be 4/3. Be sure you know how to type that into your calculator to get 4/3. 1.33333. We'll take 2/5, divide that by 2/3, so that's 2/5 times 3/2. That gives you 3/5 as your ratio. 6/25 divided by 2/5 should be 6/25 times 5/2. Reduce that and you'll see 3/5. So we're getting this common ratio of 3/5. And our first term, of course, is 2/3. So our sum is going to be the first term divided by 1 minus 3/5, which is 5/3. Okay, a ball is dropped from a height of 70 feet. Each time it hits the ground, it bounces 3/4 of the previous height. So we're dropping a ball down. It's going to go up 3/4. Come back down, go up 3/4, come back down. We're going to find the total distance that the ball travels. Theoretically, it would travel forever. So we're going to start out with 70 as our first term. We get our second term by saying 70 times 3/4. We're going to get our third term by saying 70 times 3/4 squared, 3/4 cubed, and so forth. So 70 times 3/4 gives us 52.5. $39 and a little bit. So the sum has the first term at 70, 1 minus our ratio. So of course that's 70 to the 1/4. So we're going to take the 70 and times it by the reciprocal, which is 280. And that would be 280 feet. That's how much it traveled, up and down, up and down, up and down. For 12.5, we're supposed to find the 5 terms of our sequence. So our 0 term is 3. So a of 0 equals 3. That gives us a starting point. Our first term is going to be the previous term plus 7. The previous term plus 7 more. Add 7 more to that. And then finally 7 more to that. We're going to start out with 243. We're going to take 1/3 of our 243. That's the previous term. And then we're going to add 9 more to it. So with your calculator, you would type in 243. We would times that amount by 1 divided by 3. Then we would add 9. Our second term well, that term is 90. To find the next term, we're going to do 1/3 of 90, which is a little bit easier. Of course, that would be 30. So we take that and we should get 39. One-third of 39, which is 13, plus 9 more, gives us 22. This should be a little trickier. Get a decimal value of 16 1/3. And then our final one, 1/3 of 16 1/3 plus 9. I'm going to use the exact value still in the calculator. And we get 14 4/9. Here with number, the 5th one. A of 0 is 2. Our next term is going to be that value squared minus 3, which is 4 minus 3, which gives us 1. Then we're going to say that number squared minus 3 gives us 1 minus 3, which is -2. -2 squared minus 3 gives us 1. Now we're back in that vicious cycle of 1 squared. And now we're just going back and forth. Between 1 and -2, 1 and -2, 1 and -2 if you continued it. We're going to write a recursive rule. Remember, a recursive rule needs the first term needs to tell you where to start, and then it needs the pattern of what's going on. Here we have a common difference of 2, plus 2, plus 2, plus 2, plus 2. So we take our previous term, whatever it is, and we're going to add 2 to it. We should be able to test our formula. Start with the 2. And then ANS means the previous number plus 2. So we got 4, then 6, then 8, then 10. Here we have a common ratio of 3. Our first term is 2. Our common ratio, we have 2 times, we have our R value, which is 3, and that 3 is multiplying the previous term. So what we should start with is a 2. Then we're going to say, we're going to take our 3 and times it by our answer. Then we got 6. And 18, 54, 162. You should be able to test all your formulas, all your calculations, all your answers. Here it looks like these two numbers are being added to make that one. These two numbers are being added to make that one. So our first term is 1. Our second term is 3. And to find anything else, you're going to take 2 numbers back plus 1 number back. We're going to find the first 3 iterates of the function. That means we're going to plug this in and plug it in again and again. So we're going to plug f of 0 into our function. Which is 8 minus 6. Then we're going to plug x of 1, which is this guy. Our previous term was 2. So 4 minus 6 is negative 2. Negative 4 minus 6 is negative 10. So those would be your first 3 numbers. 2, negative 2, and negative 10. We often put these funny brackets around our list. Plug in the negative 2 into your first equation. 6 plus 2 is 8. So negative 24 plus 2 more is negative 22. Which is 66 plus 2, 68. 6 squared is 36 divided by 2 is 18 minus 4 is 14. Our 14 squared is 196. Divide that by 2 and we get 98. Minus 4 from that, we get 94. Take our 94 and square that. Divide that by 2 and subtract 4. Now we're up at 4,414. Here we have a tree farm, has 5,000 trees. Each year 10% of the trees have been harvested. That means they are taking out 10%. They're losing 10%. So they're going to keep 90%. So the ratio is 90%. Their first term is 5,000. And they have this extra constant, which is 450. So we need to have a starting point, which is 5,000. And then they're asking for a recursive formula. So it has the first term. To that first term, we're multiplying it by 90, 0.90. Don't plug the previous term in because it keeps changing. A of n minus 1. And then we're adding this constant value to it, which is always 450. So what we'd be looking at is 5,000. We're going to take 90% of that answer, and then we're going to add 450 to it. So we see each year we keep changing the value, and keep changing the value. So, how many trees remain at the beginning of the 5th year? Well, at 0 years, we haven't done anything yet, we're at 5,000 trees. At the end of that, at the end of year 1, we're going to take our 5,000, we're going to take 0.90 times our answer and add 450 to it. So we get 4,950. So this is the start of year 2. For year 2, we're going to take 90 of our 4,950 and add 450 to it. So we can just hit enter. That's going to lead over to the start of the 3rd year. And add 450 to it. Push the enter again and we get 4,864. That'll start year number 4. hit enter, 4,828. So typically I would say year 1 or A of 1, but just the way I was writing these, I explained what each number was representing. So the 5th year was 4,828. What happens over time? Well, if we keep hitting and we notice that it is going to decrease, so after so many years we start to get to 4,641, 4,500, so are we going to get underneath that 4,500? No matter how many times we hit the button, you can see those decimals going away. So it's going to approach 4,500. So what happens to the tree population over time? So the total number is almost, or the smallest number actually, is almost 4,500. It approaches 4,500. Good luck on Chapter 12.